Good morning to everybody. Today we are going to discuss a finite element method unit 1 problem, that is a taper section type of the problem. Now problem statement is, for a tapered plate of a uniform thickness T equal to 10 mm as shown in figure, find the displacement at the nodes by forming into two element method model. The bar has mass density 7800 kg per meter cubed. Young's modulus capital E equal to 2 into 10 power 5 mega Newton per meter square. In addition to self weight, the plate is subjected to a point load P equal to 10 kN at its center. Also, determine the reaction force at the support. Let us start that a figure is like this. The given figure like a taper section bar. At the bottom of width is 40 mm and the center to at the end of the bar plate distance is 150 mm and the top width is 80 mm. Top width is 80 mm. Now the total length of the bar dimension is 300 mm. 300 mm. Now this is the problem. In this problem, the area of the element is varying at each cross section. If we consider this area variation, the problem will be tedious. So, the given taper bar is considered as a stepped bar as shown in figure. As a stepped bar. Now, this taper bar, I am going to divide it two elements. This is the two elements. Exactly whatever the center, this is the center. Where I am going to consider node 1, this is node 2, this is node 3. This total distance already given the input condition, that is 300 mm. Now I am divided into two elements, no, that's equally divided, that is 150 mm and 150 mm. And this first element, this second element. Now the mid node is acting in the problem itself they given the mid node is acting load is 10 kilonewton. Okay, now calculate. First of all, we are going to find out the area of this bar. Area at node 1. A1 equal to width and thickness, that is W1 into T1. Now calculate 80 into 10, that is totally 800 mm square. Now you can take in this section also take parameters, that is 80 mm. Now bottom portion is 40 mm. Now we got a area at node 1 800 mm square. Area at node 2 A2 W2 into T2. Now I don't know the area at node 2. I am going to take a average of first and second element area. Now W2 into 2 means W1 plus W3 divided by 2 into T2. Now this 80 mm is W1, 40 mm is W3, let us assume. Now this portion is W2 I am going to consider. Now the averagely I am going to consider W1 plus W3 by 2 into T2. Now let's calculate the value of 80 plus 40 divided by 2 into 10 mm. Now the value is 600 mm square. Now area at node 3 A3 W3 T3 equal to 40 into 10. Now the value is 400 mm square. Now we calculated area at node 1 and node 2, node 3. Now finally we are going to find out the average area of element A1 equal to area at node 1 plus area at node 2 divided by 2. Average, no? Now what is the value of area at node 1? 800 square. Area at node 2 600 square. Now 800 plus 600 divided by 2. What is the value? 700 mm square. Now next one is average area of element 2. Now this is element 1, this is element 2. A2 dash equal to area at node 2 plus area at node 3 divided by 2. Now what is the value? 600 plus 400 divided by 2. What is the value? 500 mm square. Now we got a value area element 1 and area of element 2. Now finally we got all elemental area node 1 and node element 1 and element 2. Now find out the given data. Now we are going to write a given data. Density equal to 7800 kg per meter cube. Now this density we required Newton per mm square. Why? Because all are maintaining a weight, no? This is the mass density weight, no? 7800 into 9.81, you will get a 7618 Newton per meter cube. But we required in mm, no? All dimensions in mm, we are maintaining in mm only. Thus we have to change this Newton per meter cube to Newton per mm cubed. Now what is the value for 6.518 into 10 power minus 5 Newton per mm cube. Now calculate the Young's modulus. What is the value of Young's modulus? 2 into 10 power 5 mega Newton per meter square. Now this also you have to convert into 10 power 6 into 10 power minus 6. You will get 2 into 10 power 5 Newton per mm square. The load also given P equal to 10 kilonewton, that is 10 into 10 cubed Newton. Now let us start first step. We are going to find out now. First calculate the body force. Body force F equal to rho A L by 2 1 1. Now for element 1, force vector F1 F2 equal to rho 1 A1 L1 by 2 1 1. First element. What is the density of first element? 7.618 into 10 power minus 5 into 700 into 150. Area is 700, length is 150 mm divided by 2 into 1. And the next one is element 2. Force vector F2, F3 7.618 into 10 power minus 5 into 500 into 150 divided by 2 to 1. 1. Now, what is the value of element 1? Element 1 value is F1, F2 that equal to 4.017, 4.017. Element 2 F2, F3 that is 2.869, 2.869. This is element 2. Now, global nodal forces. Global nodal forces. Global nodal forces F1, F2, F3. The first element 4.017, 4.017. Same similarly F2, F3 also another element nodal force is there 2.869, 2.869. Now calculate what is the total global nodal forces. Total global nodal forces 6.886, 2.869. Now we have this is F1, F2, F3. We have this is for nodal forces only. Another load we have, that is a self load. That self load also we have to include. Self load also we have to include. Now add the self load in node 1. Why? Because node 1 only is acting a force. Now add 4.017, 6.886 plus 10,000, 2.869. Now totally 4.017, 6.68, sorry, 10006.88, 2.869.